Welcome to today's lesson. Today we are looking at this theorem, which is actually the converse of the other theorem we did. The perpendicular line drawn from the center of a circle to a chord bisects the chord. Right, let's look at the situation here. We also have a circle, and then we have a chord. Okay, the circle must have a center. Now we have a perpendicular line which is drawn from the center of a circle. So we must draw a line from the center of a circle which must be perpendicular to the chord. So from the center of the circle, the line must be perpendicular to the chord. Right, so this is the situation that we have. So let's name this. Let's say the center is O, the chord is AB, and we have that. So now we must prove our required to prove here. We need to prove that this perpendicular line to the chord bisects the chord. To bisect is to divide into two equal parts. So in other words, we must prove that this line is bisecting this chord. In other words, we must prove that AC and CB are equal. So you need to prove that. So let's write it. We have to prove that AC equals to CB. Likewise, the next thing we do, which will be the first thing that we must do when we write the exam, because they will give us all this information, they will give us the diagram, they will even tell us what must we prove. So ours is just to do construction. So we will be starting with construction. So we have our construction here. We join OA and OB. Join OA and also OB. So let's do it practically. So we join OA, we also join OB. Right, so now we have the two triangles. In triangle OAC and triangle OBC. So if we look at the two triangles, we can even have angle C1 and C2. So we realize that the OB equals to the OA because they are the radii of the circle. And then we also have a common OC. OC is common. Right, we have also been given that the lines are perpendicular. In other words, C1 equals to C2 equals to 90 degrees. This is part of the given information. So we have been given that. But therefore, triangle OAC is congruent to triangle OBC. Now, what is our condition for congruency here? OA and OB. And then we have OC, which is common. We have the 90-degree angle here, but the angle is not included. So we can only go with the right angle, the hypotenuse, and a side. So the right angles, both triangles have right angles. The hypotenuse of the two triangles are equal, and we have a common side. So it means, therefore, that the two triangles are congruent. Our reason for congruency will be right angle, hypotenuse, and a side. Now, if the two triangles are congruent, it means all other corresponding angles and corresponding sides are equal. So meaning AC it's actually equals to CB. And that brings us to the conclusion of our theorem. Okay, let us look at this question that we have here. O is the center of the circle. AB equals to 8 centimeters, so from A to B is 8 centimeters. CD, from C to D is 2 centimeters. Now line OD is perpendicular to AB. Now the question is calculate the length of OC. Now this is one of those challenging questions that we can get that requires the use or the application of Theorem 1 and its converse. So the basic thing when you deal with this type of questions, you need to identify your radii. For example, the important thing, if you can be able to see that radius OB is the same as radius OD. Now these are the radii. So if you can be able to do this, then you will actually win your battle very easy, because the radii of a circle are equal. Now what is it that we must calculate? We have to calculate the length of OC. Mathematically, to make things easy, anything that we don't know, we call it X. So let's say our OC is X. So if OC is X, it means the length of our radius from O to D is the X plus the 2. So in other words, this OD is X plus 2. So which means that our OB also, because it's also a radius, it's also X plus 2. That is why I said it's very, very important to start with the radii with this type of questions. So now we know that our radius OD is X plus 2, meaning OB is X plus 2. So we can write the X plus 2 on OB. So this is X plus 2. The OB is X plus 2. Now we are also given that the length of AB from A to B is 8 centimeters. So meaning, because the theorem states that if it's perpendicular then it bisects, so it means AC will be 4 and CB will be 4. Right, now if we look at our triangle OBC, we have all the sides. We have this OB as X plus 2, we have CB as 4, and then we have OC as X. Now we can apply our theorem of Pythagoras to calculate X. So we will say OB squared equals to OC squared plus BC squared. So when we substitute, we will have OB as X plus 2 all squared, and then OC it's X squared, and then BC will be 4 squared. Right, so removing the brackets here, we will have X squared plus 4X plus 4. So we need to be careful on how we remove this bracket here. If you cannot just go straight to the answer, you might consider breaking down the bracket as X plus 2, X plus 2, and then you will reach at what we have here. So this equals to X squared plus 16. Right, so taking the X squared this side, it will subtract this X squared, so we are left with 4X equals to the 16, subtract the 4 when it comes that side, and it will give us 12. Divide both sides by 4, so the value of X will be 3. So in other words, the length of OC, in other words, the length of OC will be 3 centimeters. Thank you. Please don't forget to like, share, and subscribe. Thank you.